passed by this building a couple of times, but I think the last time I came, this was not operational. Something new they have started. So good to be here. Today we are going to be talking about functional programming. Yeah, how many of you know anything about functional programming? Okay, few of you. So it doesn't matter those who have not raised your hands. You don't need any knowledge of functional programming to understand this topic, to follow this topic. In fact, the focus will not be so much on functional programming, it will be on how Python supports functional programming. What are the things we can do with Python to enable functional programming? So that is the intent of this talk. I don't have any slides, so I have to actually be showing you some code. So I'll be sitting down shortly. But before that, Python was not designed as a functional programming language. In fact, the creator of Python, Van Rossum, he wrote a blog post sometime in 2009, and there he explained, many people think that Python was influenced by functional programming languages, which is not the case. He clarified that he was more influenced by C rather than any other language. So when the first version of Python came out, it had no functional programming constructs. And later what happened, people saw how good Python was in manipulating lists of data, like list of numbers, list of strings and all that. So when you have any kind of list processing, functional programming makes a lot of sense. So people started adding functional stuff into the Python, either in the core code, they made suggestions, or they started adding their own functions. So then, the creators of Python decided, let's bring these functions into the Python code. So early on itself, they started adding functions like map, filter, reduce, all, any. Many of these functions were contributed, you may be surprised, by an Indian guy, Amrit Prem. Right? He was the contributor for all these things. So these things came into Python in 1994. And then, along with these functions that I mentioned, there was also something called Lambda, which some people will be familiar. So that also came into Lambda. Now, functional programming has its genesis in something called lambda calculus. Right? Functional programming starts with a mathematical background. So now people who looked at this new function which came into Python, lambda, they immediately thought, okay, this is functional programming. So they started writing more and more Python code in the functional programming manner. And people got this misnotion that Python was a functional programming language. So let me clarify that Python is not a functional programming language. Not like other languages like Haskell or Lisp or any of the other languages that you might have heard. So Python is not a functional programming language, but there are some things which you can do in Python which is closer to functional programming. So you can use it that way if you want. So now let's look at the specifics. So I have set up here a notebook for this purpose.
Can you increase the font size?
Yeah. So everyone can see at the back. Yeah. Okay. So let's start with a couple of concepts. The first concept is first-class functions, and the second one is higher-order functions. So what does it mean? So I have given a simple example here, where you import the math library, and we have defined a function called add, which takes 3 arguments. First argument is a function. The other 2 arguments could be, any type, integers or strings or whatever. So it will work for integers, numbers in this example. So what this function does is, it takes these 2 numbers and individually it applies them the first argument, which happens to be a function, right? And then it returns the result. So you can invoke this add function this way, math.square root 3 and 4, which means that you are computing square root of 3 plus square root of 4, right? So this is easy to understand. So now what is happening here is, you note that the first argument to this function itself is a function. So that is the definition of what we mean by first-class functions. First-class functions is a language support. Basically, it means that the language allows functions to be passed as arguments or returned from functions. So if a language supports that, you can say that such a language supports first-class functions. So that is possible because functions themselves are treated as objects. So you can return an object, pass an object as an argument into another function. So that makes Python a first-class. Python supports first-class functions because you can do this. right? So what are higher order functions? Higher order functions are those functions which either take another function as an argument or return a function from when it exits. So those are higher order functions. So to make it clear to you, math.square root, that is not a higher order function, because it simply takes an integer, gives back, it takes a number, gives back a number. So math.square root is not a higher order function. But you take add as an example. This is a higher order function because its first argument itself is a function. So this is pretty clear. So another example of using this, so let's run this guy. So you get this answer. You can also do the same thing with another function. See, we have not changed the nature of add. We are just calling add with another function. That's it. Right. So now you can see the power of supporting first order functions and then higher order functions. Right. The behavior of the function is determined by the arguments. Okay. Next we go to something really simple. So we have here a list of colors, red, blue, green, etc. And then we do something called enumerate, which is a Python built-in function. So what enumerate does it takes the list and then for each item it adds an index. So now I have given the starting index as 50, but by default, if you don't give this is what you'll get. The default start value is 0. This is typically how we use enumerate. But you can be more specific and say that I want to start it from 50. So then, the indices start from 50. So nothing functional about this, but we'll get to it in a bit while. Note that in this functional call, I'm calling enumerate with two parameters, two arguments. One of the things about functional programming is they always try to reduce the number of arguments. Why do they do that? What is the benefit? Because as I told you, functional programming comes from mathematical background. And mathematicians, they like simplicity. So if you have a function which takes 3 parameters, x, y, z, it's harder to analyze. But if you can change this function to f of x, and then the result you pass it to another function, g of x, then another one, g of y, and so on. So what it means that mathematicians, they try to simplify the problem by taking a function of 3 arguments, reducing it to multiple functions of single arguments. Right? We will see more examples later, which will make it clearer to you. For the purpose of this example, enumerate takes 2 parameters here. We want to reduce the number of arguments. How do you do it? The simplest way is you put a wrapper. Can you see this here? Just wrap the whole enumerate in another function, call it enumerate 50, and you fix the second argument to 50. By doing this, now you can have the exactly same behavior as before, but you have reduced the number of arguments. Everyone understands this, right? So instead of calling enumerate, you call enumerate 50. Simple. Okay, so now can we do better than this? Yes. Now we introduce the second concept called closures. Right? Some of you may be already aware of closures. What closure does is, it takes a certain function, it takes an argument and then returns a function. So now closure is, one way of looking, one of the manifestations of a higher order function. So what closure does is, it returns a function. See, earlier we saw an example where function was an argument. This is the opposite, where, the input to enumerate n is nothing more than a number, but it returns a function. So let's go back to this example where we had a wrapper around enumerate. Okay? So this wrapper, we have put it inside, exactly same thing. We have put it inside here and we call it inner. And this inner is being returned by this function called enumerate underscore n. Okay? So enumerate underscore n is basically returning a function definition. And that function definition, we are calling it inner. So what is so unique about this? Enumerate n takes an argument. In our example, we are going to give an argument of 50. So what happens by doing that is, now you come, since this returns a function, you assign it to a variable and you call it enumerate 50. So this is another thing about first class functions. Because first class functions are treated as objects, they can be assigned to variables. So now enumerate 50, you may be thinking it's a variable. Actually it's a function, because enumerate underscore n is actually returning a function, which means that enumerate 50 is a function, and you can call enumerate 50 just like you did it earlier. So here you did it as a wrapper, but now you are doing it as a closure. Everyone with me so far? So this is the idea of closure. So here enumerate n is very generic. But by doing a closure, you are fixing one of the inner arguments. That's why you are able to reduce the number of arguments. So enumerate 50 is fixed to 50. Then of course you can customize it. Enumerate n, you fix it to 70, you close under 70. So this is the output you will get. Okay. Now it turns out that there is an even simpler way. You don't even need to do all this business of closure, because already Python core has support for this, and that is the next example. So under the package called or module called functools, functional tools, there is a function called partial, which many of you might have used in your code. So what partial does is, in this case, you take the function enumerate and then return a function whereby some of the arguments of enumerate are fixed to a certain value. So whatever we did earlier, this part is already being implemented by the Python core using a method called partial. So you can use that straight away. You don't have to do your own coding. So the behavior of this is very simple, very similar to what we saw in the earlier example. So now closures, we understood closures, but this partial method is actually sort of an implementation that, sort of simplifies the implementation of closures. So at any time in your code you think that you want to do some closures, you don't have to do it from scratch. You can simply make use of partial. Okay? And partial is quite important in functional programming. Even other languages, many languages that have that are functional programming languages, they support partial functions. So far clear? Understood? First class functions, higher order functions, closures, partial functions. So these are the things we covered. Now let's look at a formula, simple formula, nothing great about this. Yeah.
Is there a difference between partial and closure? I think partial is nothing but another way of getting a closure, right?
Closure is the concept, right? Partial is what I would say simplifies the implementation of closure. That's all. That is the way I put it. So take a look at this formula. Nothing great about this formula. A, B, C, and then you do some computation, you got the result. So the answer is 6.8. Remember I told you that in functional programming they like to reduce the number of arguments, right? So here we have 3 arguments to this formula. Can we reduce it to 1? So there is a method in functional programming called currying, right? So currying has nothing to do with chicken curry, right? It comes from an American mathematician whose name was Haskell Curry. So his first name they used to make a language, Haskell. Curry, has his last name gives rise to this concept called currying. So what is currying? So you have a function which takes 3 arguments, A, B, C. You can use currying to transform this function into 3 function calls. Each function takes single argument. So when I say f of a bracket b bracket c here, what it means is first you call f of a. F of a will return a function. It is not returning a result, mind you. F of a returns a function. To that function you pass the second argument b, which in turn returns another function. To that you pass the third argument c. So this concept is called currying. So the net effect is same as calling a function, single function with 3 arguments. So this is what currying is, and currying can be implemented in Python like this. Formula A, which returns f of f, which is actually a function, and then f itself returns g, which is also a function. So this is how it works, right? So currying can be done like that, but as you can see, this is also closure, right? Because once you call f of a, the value that you pass to a becomes the closing value for the other functions inside, which you will call later. Are you clear? Okay, so here one thing I want to mention is some people, they know recursive programming. So when they look at this, they get some sort of an idea that this is recursive programming. It is not, right? There is no multiple levels of stack here. Remember that. There is only one stack frame created. Because when you call f of a, it returns a function. Then you call f of whatever is returned, in this case g, you pass the second argument to that. So every time you are calling only one function, there is only one stack frame allocated. So it's not that by having 3 calls you are having these 3 stack frames.
But the above example is like recursive, right?
Which one is recursive?
First level function, first. If you scroll up,
Yeah.
still above, before closure function.
Okay.
I think above.
There.
First example where you are returning the.
This is
Remember the example number, but somewhere
This
it
one.
is like. I think this one.
yeah.
This is also not recursion.
This is also
Because
not
we are
recursion.
calling the same function, right? Earlier.
No. See, this is we are not calling the function.
No,
This
we are
function
returning-
is
we are
being
returning the
defined.
inner function, but we are calling the first function again at the upper function. So it's like repeated calls, right? Enumerate.
Underscore n.
Oh, sorry, that is not
Enumerate underscore n.
Oh,
This is enumerate.
okay.
So everyone got curry. So if you run this, you will get the same answer, 6.8. Okay. So now let's go to something different. So here we have a string, hello bank bytecode. Let's do function programming in Python. So some arbitrary string. So we
Except that partial, everything else is there already in Python 2.7, right? Because I am
partial
using-
is not there. I don't know.
Except partial,
Ah.
all other things are available in 2.7.
Sure,
Partial is also
yeah.
available in 2.7.
Because he said partial is available in 4. That's what he
No.
said.
Partial is available
In 2 and 3
Yeah.
also.
I'm sure it's available in 2 as well. So now we run a simple, expression here. So everyone knows what this is doing. We split it by the space character. Then we apply a map function with passing length as a built-in function. Length is a built-in function. So net effect is we are counting the number of characters in each word. So we don't care about apostrophes and all that. We count that as well. Doesn't matter. So here you can see map function takes length as the first argument. So map function is a higher order function. Very clear on that. So now it turns out that you can write this function in many ways. The second way is using the lambda expression, right? So lambda expression people tend to use when you have certain expression to perform, which is not available in the built-in libraries. So you have to write your own function. But the expression is so trivial that you don't want to